Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to take a look at a special right triangle with the angles 30, 60, and 90 degrees. To start off with, let's take a look at this equilateral triangle. Equilateral triangle means all three sides are equal, and therefore all three angles are equal. And because all three angles have to add up to 180 degrees and they're all equal, 180 divided by 3 would be 60 degrees. I'm going to let the length of each side equal 2 units. This is not a right triangle. However, I can create two right triangles if I bisect one of these angles, which in turn will bisect this length. And because it's an equilateral triangle, we'll create a right angle. So now I've created two right triangles, and we're going to just focus on this right triangle. So if I redraw that, we have 60 degrees here, 90 degrees here, and when I bisect that angle, 60 divided by 2 is 30 degrees. So now I have a 30, 60, 90 degree triangle. We know the length of this side is 2 units. And because this length is 2 units and this will bisect, this line will bisect this line, this length here will be 1 unit. And I can use my right triangle theorem to find this third side. My right triangle theorem says a squared plus b squared equals c squared. So a is going to be 1, so 1 squared plus we don't know b will equal c squared. C is always the hypotenuse across from the right angle. So that's going to be 2 squared. So 1 plus b squared will equal 4. Subtract a 1 from both sides. Take the square root of both sides. So b is equal to root 3. So the important thing to understand with these numbers is that the shortest side will be opposite the smallest angle. So this is the shortest side if it's 1 unit in length. The longest side, which is across from the largest angle, which is 90 degrees, will always be double that. And then the length that's in the middle, which is across from the middle angle, 60 degrees is between 30 degrees and 90 degrees. So this length has to be in between these two values. It will be root 3, whatever the shortest side is. Knowing this information, it allows us to find any two sides of a 30, 60, 90 degree triangle when we just know one side. Let's take a look at some examples. So here are the numbers, and root 3 is approximately 1.73, but we'll keep it exact until we have to round off a final answer. In this example, it's flipped, but I'm given the length across from the 30 degree angle, so that corresponds to this length here in this triangle. That means that the hypotenuse will be 2 times this amount. So this length here will be 2 times 50, which is 100 centimeters. This length here corresponds to this length on this triangle, the one across from the 60 degree angle, and it will be root 3 times whatever the shortest side is. So this length here will be 50 times root 3. So this length will be 86.6 centimeters. Now the problem with doing it this way is that sometimes people get confused of when they multiply and divide by root 3 and 2. So another option is to do these calculations using similar triangles. Two triangles are similar if they contain the same angles. The lengths of the sides don't need to be the same, but the angles need to be the same. And when you have similar triangles, the ratio of two sides in one triangle will be equivalent to the ratio of the corresponding sides in the other triangle. So let's try it again using the concept of similar triangles. And I'm going to start by finding length B. So the ratio of this side to this side, 50 to B in this triangle, will be equivalent to the ratio of this shortest side to this medium length side. So 1 to root 3. When I solve for B, you can see that it will be 50 times root 3, which we already calculated to be 86.6 centimeters. find length C, we can use similar triangles again. The ratio of 50 to C, so the shortest side to the longest side in that particular triangle, will be equivalent to the ratio of the shortest side to the longest side in this triangle, so 1 to 2. So you can see that C will equal 100 centimeters. So it's up to you how you want to approach it, whether you want to use similar triangles or whether you just want to work with these numbers. Let's take a look at one more example. I'm drawing the triangles in all sorts of orientations because you're not going to always see your triangle written like this. The thing to remember is that the side that corresponds to the 30-degree angle will be the same in this triangle. The side across from the 60-degree angle corresponds to this side, and the side opposite the right angle, or the hypotenuse, corresponds to this side. So 2 ways we can approach this, and I'll show you either way, and you choose which method works for you. We're given the side opposite the 60-degree angle, which corresponds to this side. In order to find the side opposite the 30-degree angle, I'm going to just divide that by root 3. So 30 divided by root 3 will be equal to 17.32 inches. Once I've got the side opposite the 30-degree angle, I simply double it to get my hypotenuse, because this is always going to be 2 times that. So in order to get this, I double 17.32 and I get 34.64 inches. This method might be preferred by some people, but others might get confused. When do they multiply or divide by root 3 or the number 2? So what we're going to do is redo this using similar triangles. So in order to find A, I'm going to use the ratio of these 2 sides, which is equivalent to the ratio of these 2 sides. So A to 30 in this triangle will be equivalent to the ratio of 1 to root 3. We cross multiply. Root 3 times A will equal 30. Therefore, A is equivalent to 30 divided by root 3, 17.32 inches. To find side C, I usually like to work with the value that was given in my ratio rather than one I've calculated. So I'm going to continue using this, and the ratio of C to 30 will be equivalent to the ratio of 2 to root 3. It has to be in exactly the same order. So if I'm taking my hypotenuse to this side across from the 60-degree angle in this triangle, I have to use the hypotenuse over the side opposite the 60-degree angle in that triangle. Cross multiply, so root 3 times C will equal 60. Divide by root 3, and we will get 34.64 inches. So either method is fine, it's personal preference. But knowing the special relationship between the sides in a 30, 60, 90-degree triangle allows you to find any other 2 sides when you know just one side of the triangle.